All right, so we're going to do lesson 1.3 today. There's only 3 activities with this, and you guys shouldn't have any homework, which is nice. But we are going to do 1.3, surprising spider silk. All right, so our closing task today, you guys are going to be able to create a model showing how protein structure determines function. All right, so for the warm-up, we are going to watch a video after the warm-up, but what I want you to do is list 1 or 2 questions you have about bark spider silk before watching the video. Okay, 1 or 2 questions. It can be about whatever, not whatever, but bark spider silk. Anything that you would like to know about bark spider silk before watching this video. Okay, so go ahead, go into your warm-up. I only need 1 or 2 questions there. 1 or 2 questions. All right, it can be about the spider silk. It can be about the spiders. Really anything about those spiders. We didn't learn too much yesterday about how they produce it, how scientists look at it. So just record any questions you have. And then press hand in when you're done. Take about 2 minutes to get this done, and we're going to move on to the video. Take another 45 seconds. Make sure you get that done and hand it in. All right, so in the last lesson on Tuesday, we watched a video about a real scientist who studies spider traits. And so what we're going to watch now is a follow-up video about how scientists study spider silk. And so spider silk, I told you guys last lesson, is what we're going to be taking a deeper look into. All right, so let's go ahead and watch this. I'm going to share my sound.
And then how about this spider? So much is not known about spiders and spider silk. For most of the questions, we actually have to go outside, get spiders, bring them back into the lab, and research on them. This is a Western word for you. What we're going to do. Let's start by first
All right, so that's our video on a little bit more about spider silk. Okay, so what we're going to do next is we're going to investigate a little bit more. We're going to review our investigation question, and then you guys are going to read and annotate an article, and then you're going to choose one other article to read and annotate. So these articles are actually pretty short. There might be a page or less. So we're going to go ahead and go on to those. So you guys remember that we are investigating differences in the silk flexibility trait of a spider family. So in the previous lesson, we investigated differences in traits by observing the cells of different spiders in the simulation. So you guys remember that sim that we looked at? And we saw that there were smaller cells all together, clumped together, and then in the sim, it showed us a bigger enlarged picture of a cell. Had a nucleus, had ribosomes, and had some protein molecules kind of floating around. So we're going to be investigating this question. What determines an organism's traits at the molecular scale? Okay, what determines an organism's traits at the molecular scale? Okay, so today you guys are going to read a short article that will help you understand some of the important things that scientists already know about variation in spider silk. And so you guys remember when we talked about variation, we put that in our digital notebook. Somebody tell me what variation means. Y'all can put it in the chat. What does variation mean? Okay, Natalie said a widespread of different things. What else do we have? What is variation? Okay, Mackenzie said any difference in traits between individual organisms. Good. So we know that variation means something's different. Okay, but in science, in what we're studying here, variation means any difference in traits between individual organisms. Okay, so if I have blue eyes and somebody else in this class has brown eyes, that's variation because we have a difference in traits between us. Right, so you guys should know how to use the Amplify library. We're not going to go over that. You guys know that you can underline, you can highlight words, and then you can add text to the articles, okay? So we're going to read this first article together, all right? So go ahead, go into Amplify. It is the second tab. We're going to read this first article together. All right, so you should be on tab 2 in Amplify. And it should have this spider web as the first picture there. So while I read this first sentence, you guys kind of just follow along. So you should be on the article that says different silks for different functions. All right, so this first sentence says, deep inside the body of a spider, specialized cells produce protein molecules that are much longer than the ordinary protein molecules. These long protein molecules connect to form an amazing material, spider silk. All right, so you guys may be unfamiliar with the term specialized, and so I'm kind of just going over what you can do. You guys know that you can highlight. So maybe if I'm not familiar with the word specialized, I can highlight it, leave a note, and remember to discuss it. Okay. So specialized could possibly mean the same as special. All right, let's finish reading this article or the introduction together. So I'm going to go into Amplify, exit out of this. I'm going to read the rest of the short article. I think there's only about 2 more paragraphs left. All right, it says spiders use their silk to build strong webs to trap bugs, to save themselves from falling, to wrap their eggs safely, and even to glide through the air. How can one material, spider silk, be used for so many different functions? Different uses for spider silk are possible because not all spider silk is the same. There are many variations or differences in spider silk. This is because there are different features of spider silk, such as strength, stickiness, stretchiness, and color. For each of these features, there are several possible traits. For example, for the feature of silk color, a spider might have the trait of making gray, white, or even gold-colored silk. You guys may have not known that before, but here is gold-colored silk. All right, spiders have different traits for each feature because of differences in protein molecules that make up the silk. The cells of different spiders make different kinds of protein molecules, and these molecules combine to make different kinds of silk. This means that the kind of protein molecules a spider makes for a feature determine its trait for that feature. The spider pictured above makes specific protein molecules for the silk color feature, and these protein molecules result in gold-colored spider silk. It says to learn more about some amazing spider silks and the proteins that make them that way, read one or more of the chapters that follow. Okay, so if you guys scroll down, if you're looking at my page, great. If you're not, then you can scroll down on your page and you should be able to click next on this. And so what I want you to do is I want you to go through some of these articles, see which one you would like to read. None of them are more than like 2 or 3 paragraphs. Most of them are only 2 paragraphs that you guys have to read. But what I want you to do is I want you to pick one of these articles. Okay, pick one of these articles. And then what we're going to do in the chat, I'm going to put a link to what's called a Jamboard. I think you guys might be familiar with a Jamboard. If not, it is pretty simple, and you'll click on the link and add a note. Okay, so what I want you to do right now is to pick an article to read, and I'm going to give you guys about 4 minutes to read that short little article. I think that should be plenty of time for you guys to read and then to add a note on our Jamboard. Okay, so take about 4 minutes, and I will give you guys the link to the Jamboard. All right, so I posted the link to the Jamboard. You guys should be able to click on that link, hopefully, and it will take you to something that looks like this. And so somebody already asked what you should put in this Jamboard. And so what I want you to put in this Jamboard is something that you learned, maybe something that stood out to you. All right, hold on just a second. And I'm going to share it again because I think it's private. So hold on just a minute. Don't click on that link. I'm going to give you guys another link. Hopefully that works. y'all are able to get on it. What I want you to do is I want you to put something that you read, maybe that's interesting, maybe something, uh, maybe a quote, okay, maybe something that you learned. All right, so whichever article that you did read, go ahead, you guys can add a note to this article. So if you want to add a sticky note, you can add a sticky note, which is the fourth little button down. So you can just add a sticky note like this and drag it to whichever article that you read.
It says view only.
Oh, it says view only? Okay. Let me try to figure it out. Gotcha. I figured it out. You can edit it now. Thanks for letting me know. I'll post the link again just in case it's not working. All right, is it working now, guys? Hopefully you can add a sticky note to it. Perfect. All right, so just make sure that you are adding it to the correct article. That article is named on those sticky notes, okay? So hopefully you guys didn't read the same article. Whichever one, I gave you a choice. So whichever one that you read. And after you have written one on here and added your sticky note, go ahead and start reading some other people's sticky notes. All right, so make sure that you're adding any quotes, anything you learned, maybe something interesting from that article. All right, so spider use their silk as a sail to move through the air. So I think somebody else said that. The weight of spider silk can change. Some spiders have the trait for a kind of lightweight silk called gossamer. I think that's how you say it, silk. All right, somebody read something about venom. So spider silk has venom, and whenever it sees prey and shoots silk at it, and the venom kills their prey. That seems interesting. All right, a few people read living underwater. So the silk net keeps water out, but lets oxygen in. That's very special silk, and that's all thanks to the proteins that make it up. The spiders carry bubbles down to the silk net, filling the net with air. Did anybody read the spider silk for supersized webs? Anybody read that one? Nobody read that one? I should have some more on here since there are 23 people in here, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people. 11 out of 23 people have read an article. All right, so if you have not read the article, you need to make sure that you read it and then that you are adding to our Jamboard. All right, so who is this? Somebody read the supersized webs. So super webs are made from incredibly strong silk and can stretch across large spaces. All right. So if you have not read an article, you need to make sure that you are reading an article and adding to our Jamboard. Thank you to those that have already done it. But we are going to move on. I'm going to keep that Jamboard open just in case you're just a little bit behind. So hopefully more people add to that Jamboard. All right, so the protein molecules that make up the silk allow the spiders to do many different behaviors that can increase the odds of survival and reproduction. So you guys, hopefully you guys know maybe a little bit about spiders, but if you don't, when a bug flies into their spider web, the spider kind of wraps them in that silk and then will eat it. All right, so the stronger that silk, maybe it increases their odds for survival, right? They don't want that silk to be lightweight or not strong, not flexible. And so this new word that you guys are seeing, protein molecules. Some of you pointed it out last class, talking about when we talked about the family tree, you talked about something with the protein going on in the body or in the cell. And so we're going to write this down in our digital notebook. So this word protein molecule, technically two words. All right, so a protein molecule is a type of large molecule that performs important functions inside organisms. A protein molecule is a type of large molecule that performs important functions inside organisms. All right, so add this to your digital notebook. All right, I'm going to move on to our next slide. So this model of a protein looks different than the model that you guys saw in the simulation. So this one shows a more realistic three-dimensional shape of a protein. So what we saw in that sim yesterday were those little red pieces. Actually, let me see if I can go to it real quick. I'm going to go to 1.2 and show you what I'm talking about. So when we looked in the sim, you guys saw these little red things. Okay, these were the things floating around in that cell. So those are the protein molecules. Right, that's what that was talking about. But this is an actual 3D model of a protein molecule. All right, so we're going to move on to the last activity, which is it's a modeling activity, kind of a hands-on activity that you guys can't really do at home. So Mr. Living Good has made us a video or a Edpuzzle to do. Okay, so we're going to complete that in Canvas. And then we're also going to add the definition of function and a key concept to our digital notebook. All right, so before we get into that Edpuzzle, you guys just read about the types of silk that different spiders can make. And so we're going to use a model to learn how protein molecules determine silk flexibility in Darwin's bark spiders. And so remember, we are investigating this question. What determines an organism's trait at the molecular scale? Okay, what determines an organism's trait at a molecular scale? Somebody tell me what you think about when we talk about molecular or molecular scale. Y'all can put it in the chat. So what am I talking about when I say molecular or molecular scale? Okay, Natalie said molecule. So those are two close things, but what do those two things have in common? So a molecular scale, at a molecular scale, what could that possibly mean? Right? Momini said the molecule size, and Natalie said a small scale. Okay, good. So we know that molecules are really small, and so molecules and molecular have something in common, right? When even their wording. So we can assume that that is a small size. So we're looking at an organism's trait at a smaller scale. Okay. So scientists use models to represent things on the molecular scale, which are difficult to observe. And so in the sim, we saw this model of protein molecules. And so that's what I just went over. Those little red things in that picture are protein molecules. And you saw, if you were paying attention to what those were doing, some of them were staying in here. They were kind of just floating around. And then you had some of these little exits where they were going out. All right, so Mr. Livingood made, like I said, he made a video for us because we can't do this at home. All right, we don't have the materials to give you all, to give every single person something at home. And so before we get started, I want us to put this in our digital notebook. All right, so structure. You guys have probably heard of structure before, whether it's in school or outside of school. And so structure in this case is the way something is shaped or constructed. So the way something is shaped or constructed. All right, so in science, when we describe the structure of an object, we describe its shape. So if you're looking at this wheel, it has a circular structure, right? If you're looking at a building, it has a rectangular structure, right? So this has a certain type of structure. And so we're actually going to go into Canvas. And what I want you to do is go into the Ed Puzzle. So you should see the attendance. You should see lesson 1.3, surprising spider silk. And then you should see lesson 1.3, activity 3, Ed Puzzle. So what you're going to do is you're going to go ahead and click on that. This is kind of on your own. So what I want you to do is to do this right now. You've got, I think there's 4 questions maybe in there. Last time I looked, maybe only 3. There's only 3 questions. It's a 5-minute and 20-second video. So you can go ahead, watch that. I'm going to give you guys about 7 minutes. So we're going to hop back on here at 10:49. So 10:49, I'm going to give you 7 minutes. Make sure you get to it and watch the video. All right, remember it's in modules under today's date. All right, y'all. So hopefully you are done with that puzzle. If you are not, then you can come back to it as soon as we're done. We're going to get out of here just a little bit early. But let's go ahead and move on. Just pause that puzzle video if you are still working. All right. So Mr. Livingood, when he was doing that video, he said a lot of things about function. So how something works. Okay. Go ahead and add that to your digital notebook. All right. So function is how something works. All right, so we know that the structure of a wheel is circular, okay? But the function is going to be to roll over the ground, right? So a wheel illustrates both structure and function. So wheels roll across surfaces and can help move other objects. And so the structure of a wheel allows it to serve this function. All right, so what did you guys, this is the last, I think this is the last questions that I will give you guys, and then we're going to look at a key concept and we will be done. But what did you guys notice about the function of the protein molecules in this model that Mr. Livingood was going over? And did they serve the same function? What did you guys notice about the function of the protein molecules? Y'all can put it in the chat or you can unmute yourself. So what did you notice about the function of the protein molecules? Okay, so I said they all work together. You are correct. All right, so some protein molecules may be, you can say, stiff. They all had different functions. So they didn't all serve the same function, right? They were different shapes. Okay, so Natalie said even though that they had different functions, they all helped each other in some way, right? Okay, so if there was an error, they may not be able to function or do what they are there to do. Good. If you have not finished that video, just make sure you finish the video as soon as we are done here. Okay. So the last thing that I'm going to give you guys is this key concept. So this key concept is going to go where it says 1.3, so lesson 1.3, where it says important information or important ideas. Okay, so the function of a protein molecule depends on its structure and how it interacts with other protein molecules. All right, so you guys have pointed those out. So the function of protein molecules is not always the same. It depends on its structure and how it interacts with other protein molecules. All right, so make sure you get that into your digital notebook. The last thing that I want to tell you guys about is the weekly check-in. So I have not unlocked that just yet, but I will do that right now once we get out of here. Allison, you put this in your digital notebook. So when you're up here, it should say chapter 1, lesson 3. So that's what we're on today. You should have put it in important ideas. And if you guys ever have any more like important ideas or things you would want to write down in here to help you study, then you can do that as well. So here's our key concept. I'll leave this key concept up. You guys make sure that you do the weekly check-in in Canvas, and that is the only homework that you have for me. Get that done as soon as possible. I will probably grade that on Sunday night. Okay, on Sunday night, you should have that done, and I will see you guys on Tuesday. Okay, you guys have a great weekend. Bye, Liz.